Okay, we already get through the fundamental for differential amplifier. And now the second part will be operation amplifier. You understand this is the symbol for differential amplifier. They get your input, okay? One will be inverting, okay? Negative. And another one will be non-inverting, okay? And one output, okay? In the fundamental for differential amplifier, you get two output. However, in this case, they're using only one output, okay? And basically, they're telling you inverting input, that will be a minus sign, okay? And non-inverting plus sign, okay? And also, basically, input impedance, they want to be infinity. That's only telling you they don't want any current flowing into the op amp. Okay? And the difference between input positive and input negative, okay? They want that to be equal 0. You can see that. Okay? Differential input VD equal V at positive minus V at negative equal 0. That only telling you V at input positive will be equal V at input negative. Okay? And in the output, you see what they want. They want the gain equal infinity. Okay? And the output impedance, they want that to be 0. So when you're looking into the symbol of the op amp, basically you have to remember that information in order to keep moving. And you can say that will be the IC you will be using in the level. Okay? Okay. So now that will be more practical op amp. This is the IC here. Okay. They get only 8 pins. The power supply. Pin 7 for positive. Pin number 4 for negative. In the left volt, we're using plus 15 volt and a minus 15 volt. Okay. And pin number 2 for inverting. Okay. And number 3 for non-inverting. Okay. That's only thing you need to know. And practical op amp, they get the high voltage gain, very high input impedance, and very low output impedance. And there will be a wider bandwidth that they're asking for. Practical op amp. And this is a summary. Okay. Output voltage Vout equal V in positive minus V in negative time A O L. A mean gain. O L mean open loop gain. And VD, the difference between two inputs, we already know. VD equal Vs positive input minus Vs negative input. Okay. And they're supposed to be equal. The thing is VD will be equal 0. And the gain, okay, for the open loop gain, that means when you go together, IC only, not any connection. The part number is 741. Okay. And the gain flow will be 200,000. See that? That's too big for 200,000. The output of amp is never higher than power supply voltage. That's a very important to you. Okay. The thing is, you see, the gain they say had 200,000. So we don't want to working with the circuitry with the gain is too big. Okay. However, they already telling you output of amp never higher than power supply voltage. We're using plus 15 and a minus 15 volt power supply. That's telling you output cannot be higher than 15 volt, okay, or minus 15 volt. When input apply is too high, yeah, then the op amp they said will be into the saturation. Okay? Saturation, that means they no longer amplifier. Okay? And the op-amp output will be equal plus minus saturation voltage. And the saturation voltage all the time will be less than power supply about 1.4 volt. Okay? So that will be more safety to working with the op-amp. If you increase the input voltage too high and the output cannot be amplified anymore, there will be saturation. Open loop gain, AOL, is defined as the amplifier output application without any external feedback signal connect to it. And for a typical operational amplifier is about 100 decibel. They're using a decibel, okay? And this one we already given to you last time, okay? They given you the op-amp open loop gain, 200,000, okay? Power supply, 15 volt, and minus 15 volt. And also they given a voltage saturation. Normally they will be less than 15 volt or minus 15 volt, 1.4 volt. However, in this example, they given you the same, okay, 15 volt. That doesn't matter. And now they given you input positive, input negative, and they want you to get a VD. You already know VD. Vs positive minus Vs negative. So 20 microvolt minus 240 microvolt. So the VD will be equal, okay, minus, oh man, okay, $20, okay, microvolt. And you take a 20 microvolt times to 200,000, you get a V out, okay. Anyway, if that V out higher than 15 volt or minus 15 volt, op-amp will be saturation, okay. And when they be a saturation, V out will be equal saturation voltage. Okay, now input signal. The first one, they connect input for input sideway to a negative, and a positive input they connect to ground. Only one input, okay? Input apply to either positive or negative of the op-amp and the other input connected to the ground. So the second one, they apply signal to a positive. Okay? Yeah. And the negative will be ground. Or they can apply to both input, negative and positive, and you can see, okay, when they apply, okay, signal V in 1 to negative and V in 2 to positive. Only one thing you have to recognize the input applied, they must be opposite 180 degrees our phase. If the V in 1 go up, V in 2 have to be going down. They cannot be the same. Okay? That is a very important. Input offset voltage. Okay? The ideal of amp produce 0 volt output for 0 volt input. However, in a practical op amp, V out appear output when no different input voltage is applied. Its primary cause is slight mismatch of the base emitter voltage of the differential amplifier. Okay, as a specified on an op amp data sheet, the input offset voltage VOS is a differential DC voltage required between the input to forcing the output to be 0. That's only telling you when you connect both input positive negative to the route, output supposed to be 0. However, they're not quite 0. So that they can get 1 millivolt or 10 millivolt or minus 5 millivolt. That's what they call a offset voltage. They're supposed to be 0. Now, they given to you. How can we adjust the offset? This one you're supposed to be doing in the left volt. Okay? Adjust the offset voltage. Connect the port to the pin 1 and 5. Okay? That means on the pin 1 and pin 5, normally they not connect. However, that is using for the offset. Okay? So, pin 1 connect to pin 5. Then, connect both input to the op amp to the route. That means you connect input negative, input positive to the route. Output supposed to be 0. If they not 0, adjust the port, okay, until the 0. Okay, adjust the port until V out close to 0. So if you understand on that one, you have no problem. When you do left volt up to the point, you need to working on offset voltage. Okay, now open loop and a closed loop gate. On this one here, you get input V in negative, V in positive, and no connection. The gain will be V out divided to V in. That V out. And that will be V in. However, now, for the circuit we're working on, that will be low loop gain. Now they connect the output to the input with a resistor RF. That's what they call feedback resistor. Okay? And R in, that will be input resistor here. Okay? And they given you the gain now have to be equal minus, okay, RF over RE. That will be inverting amplifier, we'll see. Okay, sometimes a lot of students cannot understand how that will be look like for you. Okay, you understand for this side, go up, they will talking about the gain. Okay, AV. And they're using a decibel dB. Okay? And on the right, go to the right, that will be the frequency vary in hertz. So at the signal DC, that means no frequency. So if you going up, you can see the gain will be 100 dB, decibel. Okay? And the gain, the frequency 10 power of 0 equal 1 hertz. Then the gain still 100 dB. Okay? And now, at a certain point here, okay, go to the frequency 10 power of 1, that means 10 hertz. And the signal, the gain will be going down. Okay? At 3 dB point, that's a critical frequency, they going down 3 dB. Okay? That only telling you one thing. When you try to increase the frequency, okay, then the gain will be going down. If you're looking into this point right here, okay, if you want to see the frequency you going down, 10 power of 2 mean 100 hertz, and you're looking for the gain, they go down to 80 dB. Okay, so the bandwidth will be wider, and you keep going. Okay, to this point, then 10 power of 3, 1000 hertz, and the gain go. Okay, 60 dB. And the last one, at this point. Frequency go to 1 megahertz, okay? And the gain will be 0. Okay, now inverting operational amplifier. So they connect the circuitry this way. They get RF connect from output to input. Okay, and you get the input resistor in. On the other side, they connect V1 to the ground. Okay, one thing we already know, VD, right here, V different equal V1 minus V2. And they want that to be a 0. Only telling you one thing. V1 will be equal V2. Now, at the point here, they will be around. Right here, you see, virtual round. And this point also the round here. So you get two different rounds. This point, they call a physical round. Okay? On that open up here, the round they call a virtual round. So what is the difference between physical round and virtual round? Physical round, that means you need the wire connect to the round. Okay? And virtual round, you see, they don't have a connection wire connect directly to the route. Okay, so basically, when the current flow into input through in, okay, that current go to the point virtual route here. First thing, that current cannot go into the op-amp. We already telling you. High input impedance. Okay, and also this current cannot going down. Why they not going down? The reason is input at positive, input at negative equal. That means they get the same potential, so they're not going down. Okay, so this current will be going up. Okay, that we call IF. They going to IF. So basically, one side IF on the left side will be positive, and on the right side will be negative. Okay, so you get a negative here, and you're going down here. The current at the output you get the negative on I out. Then the other side here, they have to be positive. Okay? So when you get a positive here and a negative at the output, that's only telling you one thing. The current go to RF, they cannot going down. They will be go into the op amp. That's what we call a op amp sink current. They pull the current in. And also at the V out on the downside here, positive, better than the other side. So you get another current will be IL going from round up and go into the op amp. That's what we call I load. So op amp will be sync current, IF and IL. Okay. So in here, they say IF feedback resistor between output and the inverting input to produce closed loop gain, ACL. No current flow into input terminal. High input impedance. The different input is zero. So VD equal V1 minus V2 equal 0. They're telling you V1 equal V2. Closed loop gain, ACL. That means the gain will equal minus RF over RE. That's for inverting amplifier. Okay, so this is more detail for you. They apply 5 volt to VE. Okay, and the resistor R1, 1K. Resistor RF will be 1.5K. Okay, and the current flowing from 5 volt go to R1 and they go to virtual round right here. That virtual round equals 0. Okay, again, all the time, make sure you understand VD, the difference between two input equals 0. So that's why VS positive, VS negative equal. So you get a physical round here. Okay, equal 0. So on this, the virtual round is in here. You also get the 0. And the current I going from 5 volt to this point is 0. Okay, and this current cannot going down. The thing is V1 at virtual round and V2 at round at the same voltage, so they cannot flowing down. They cannot flowing into op amp, high input impedance. So they go up. You see that? You get a current I going up. So when they go through the RF, then the positive, this side must be positive when the current coming in. And when they leaving RF, this side have to be negative, and this side negative. And at the V out, they have to be negative. The thing is just a wire connection. So the current, and also you can see at RL, one side negative, the other side must be positive. So also you get a current IL. They going from positive to negative. When they go up to V out, they will be going into also. Okay? In this case, we call the op-amp a sink current. They put the current in. And now, this is the on of the calculation. Make sure you understand. First thing, you want to calculate the current I. I equal V in 5 volt divide R1. So you get 1.5 milliamp. And then you calculate the V out. Okay? V out equal voltage gain times V in. Voltage gain equal minus RF over R1. Okay? So that's why you can get minus 1.5 times 5 volt. And output you get a negative minus 7.5 volt. And now you want to calculate the load current. Okay? That means the current IL. You take 0 volt minus the V out divide IL. You get 1.5 milliamp. Okay? So you get two current go into op-amp. Okay? And that's what we call I out. So I out op-amp current will be I plus IL. You get 6.5 milliamp. So try to make it clear to you on this circuitry. Okay? That will be help a lot. Any question, anything? The thing is you get a lot of assignment for take one. Okay? You have to working on assignment. To upload it. Okay? We check it out. If you cannot get through it, that means you still want to study, you want into the program, no big deal. But you cannot get certificate anyway.
Mr. Pham, quick statement or question.
Go ahead.
Just so they know, R2 and RF are the same thing. You put RF up there, but in the formula you put R2, but they're the same thing.
RF, that means.
No. RF and R2 is the same, correct?
What do you mean RF, R2?
RF.
Yeah, that's what I tried to explain to you. RF, that's the thing in the theory. They make sure you understand that a feedback resistor.
Okay, right.
However, in the practical circuitry, they can be R1 or R2, R3, and they are.
Hmm.
Okay?
And then the other thing is in the where you got load current IL equals zero, the zero comes from the fact that the plus side is ground. Is that right?
Right. That route, physical route.
Right. So that's why you got zero there.
And the other side, V out is minus. The current have to be flowing from positive to negative. So that's why they go up.
Okay, good deal.
Okay? So if you are still not clear, okay, try to make it, okay, that is, if you understand when you're doing either assignment or you're working on the level, will be no problem. Okay, now this is from the left volt, okay? Again, when I talking about the left volt, I don't want you to keep reading all of the thing in the left volt. This software for the left volt, they developed about 10 to up to 20 years ago. Okay? If you want to go through everything, take you around 2 years to get through the left volt. That's not supposed to be. Okay? So that's why when you go into the left volt, they can explain to you, they can ask you a multiple question, A, B, C, D. Okay? So if you want to read later on, then you need to copy that and save into the PowerPoint. So when you get the time, you can read, or when you need it, you can read. However, that phone using for Take One program is working on that. I only want you to working on that. That means you can know how to using the meter, a generator, the oscilloscope, okay? Try to working on the circuitry. That is very important, okay? The thing I already been in a class, I saw a lot of people try to take a note. No, don't do that way. You want to keep to read later, make copy and save to PowerPoint, okay? If we get the time, you can read, okay? However, for technician in a Tech One, I given you the circuitry, given you the input. I need you to measure the output. Okay? Now, for this circuitry, they want the gain ACL. So when you're looking into the circuitry, you have to know the configuration of the op-amp. Inverting amplifier, non-inverting amplifier, summing amplifier, and so forth, so on. Okay? So this is inverting amplifier. And we already know the gain will be minus R3 over R2. That means 10K divide 1K. That's what you get a minus. Okay. And if you want a V out, you take that gain time input is 1 volt. You can get a V out. And they want the current I through R2. That means the current flow here. Okay. This side will be round, virtual round. This side 1 volt. So you take the Ohm law. Okay. 1 volt divide to R2 1K. That's what you can get current I. And now they want to get a load current. That means the current flow in through R5. So basically, they will be the different voltage 0 volt minus V out. Okay, divide 10K. Okay, that's what you get the current IL. And the last question, they want to know the op-amp current. You adding I, out, IL, and I. So you can get the output current. Output current go into the op-amp. In this case, they sink current. They put the current in. Okay? Any question for this example? Okay? And now, on this circuitry example again, they apply sideways. Okay? 1.5 volt peak to peak, frequency 1 kilohertz. Okay? They want the closed loop gain. ACL equal minus R2 over R1. They want V out. You take the gain time sideways. Okay? 1.2 volt peak to peak, you get V out. And now they want current through R1. Okay? That means you can take the V out, you divide R2, 4.5K. Okay? And also, they want the current through R1. You take 1.2, divide R1. Note, input output is inverting or 180 degree. Okay? Our phase. So that's why you can see this is the input here. And the output will be opposite. Okay, any question about this example? Okay, if it's not, we keep moving. Okay, now we go to another one. There will be a non-inverting. So that's why when you're working on a op-amp circuitry, you have to recognize, is it inverting or non-inverting? So for non-inverting, they connect the input, okay, V1, 5 volt, okay, go through R2, go to the positive, and on the negative, they connect R1 to the ground, and RF connect from output back to the negative input, and you understand a this point connect to the negative, okay, and this point connect to the positive input. That means input at positive and negative they equal 0. That means the input they will be the same thing. Okay? When you're working on the op amp, the input have to be at this point, not V1 here. Okay? The input have to be connected directly to the positive. So they given you 5 volt V1 and you get two resistor R2, R3. You can using voltage divider to calculate the V in. You see that? V in equal 5 volt times R3 divide R2 plus R3. You get 2.5 volt. So when you get 2.5 volt at this point, and the question is, on this point here, what voltage at the negative? They have to be 2.5 volt. Why? The thing is they already telling you, the difference between positive and negative will be 0. That means whatever voltage here will be the same voltage here. And you get a 2.5 volt here. So at this point, also you get 2.5. Okay? If you get a 2.5 at this point, the others of our one round, you can calculate the current I equal 2.5 divided 1K. So get the current I. Okay? And this current I here, basic coming from output here. Okay? That current I here. The reason is no current flow in here. The thing is they get the same potential. Okay? So if you want to calculate that current, you take 2.5 divide to R1. So you get that current through R1, and that also the current I here. Okay? I here will be the same I at the output. So they're telling you the current, that current I coming out from op amp. Okay? In this case, they call a source current. Op amp send the current out. Also, on the V out, now they will be positive. See that? And the other side of load will be negative. So you can get the same thing. I load current coming out from op amp going down. Okay? So everything they already given to you in here. Okay? You can go through that and try to get all of the thing we need to know for the non-inverting. Only thing will be very important to you. For the non-inverting, the gain of amplifier after calculation, they will be equal 1 plus RF over R1. That means the gain all the time will be greater than what? Question. Okay, now this is the example. If I'm looking into this op amp, you have to recognize again, is it inverting or non-inverting amplifier? If you're looking into the input here, they go to the positive. They're telling you non-inverting. Okay? And RF, that means the resistor connect from output of the op amp back into the input of the op amp. Okay? Input Vin connected to the non-inverting input of op amp. Closed loop gain ACL equal 1 plus RF over R2. Okay? Input and output is in phase. Okay? For the circuit show, they given you RF, R2, V in, and they want to solve for ACL. You already know ACL equal 1 plus RF over R2. And they want V out. Take V in time the gain. You get V out. And now they want the current through R2. That means the current go through R2. Okay? And now in order to calculate the current go through R2, you have to know the voltage here and the other side ground. You take this voltage, okay, divide R2. That's how you can get the current through R2. So you can try that, okay, to make sure. Okay, now next one, that's it. Okay, that's an example for non-inverting and for inverting. Okay, you can try to see you can get through that.
Mr. Pham,
Yes, sir.
I don't know if you like this or not, but are we able to like build these circuits in the multi-sim 7 and then see how it works?
Yeah, you can do it. No problem.
Okay, thank you.
You understand if you get to simulation program, PSPI, and MSIM7. That means you get a circuitry, electronic, you can run the simulation, you can using both. However, you must understand the difference. PSPI, that will be more theory. You can run, you can get any value you want. However, MSIM7, that will be a practical simulation. That means you have to know how to using the meter, how to using the generator, oscilloscope to measure exactly what technicians have to do at work. So that's why take one up to this point, we not teach you P-SPI. We already talking about MC7. Okay.
Yeah, for instance, Mr. Pham, take the one on top where it's 220K ohms and 10K. You just build it just like that, put a voltage at the VN, and then take the measurements, and you can find out that way. Do you
Exactly.
agree? You
Yeah.
agree?
Yeah.
Okay, thank you.
Remember the given UV in. You want peak to peak. Okay. That's a very simple. You draw the simulation in MSIM7 and they telling you whatever you want. Okay, now next amplify. Unity gain. Amplifier. If you see the circuitry connected way, direct output to the negative, that will be unity gain. That means the gain equal what? Input output the same. Also, they get another name. They can call a buffer amplifier, okay, or the follower, okay, or isolation amplifier, and the gain equal 1. Now, how come we need that amplifier? The thing input output the same thing, but you need this amplifier, especially on the power supply. Like your computer, you need the power supply. In any power supply output, they need that amplifier. That means the input output will be the same thing. Okay? You guarantee one thing, input and the output will be isolated. Okay? If you want 5-volt output, and now you apply input 20 volt, okay? So they're not working. That means the output cannot equal 20. Okay? So that will be limit the isolate between input output. Otherwise, they can go to the output 20 volt, you get big problem. Okay? Like one summing amplifier. That means using inverting amplifier. Input they get V1, one input, two input, three input. Okay? And they make a connection this way. V out will be equal minus sign of the total V1 plus V2 plus V3. That's what they call a summing amplifier. Okay, let's see. That's what they're talking about. Slew rate. The maximum rate of changing of the output voltage in response to a step input voltage is the slew rate. That's just a definition for slew rate of the op-amp. The slew rate is depending upon the high frequency response of the amplified state within op-amp. Okay? So basically, you get the input here. Okay? They go from minimum, okay, V in, they go from 0, okay, negative up to the positive, okay, and they need to calculate the slew rate. They say equal delta V out, okay, divide delta T. So basically, this unity gain input output will be the same. However, they're not. You see, input going from negative to positive go straight. However, output they not go straight. Okay? You see, they go this way. Take a little time. Delta T go up. That's what they talking about. Slew rate equal delta V out divide delta T. Okay? And also, they're telling you delta V out equal V maximum minus U minus V maximum. The unit of the slew rate is volt per microsecond. Let's see. We can get an example here. Okay, they given you an example. Okay, you could go through the solution. Okay, and try to see, how to calculate that. Okay. Now, what they talking about? Gain bandwidth product. This circuitry here, okay, they using inverting or non-inverting. Will be input apply positive, non-inverting. Okay. They say increase loop gain cause a decrease in the bandwidth. Unity gain bandwidth formula equal ACL gain time FC. Okay. And in here they given you the example. Try to make sure you go through the example. You know how to do that thing. Okay. Determine the bandwidth of each the amplifier so both of them have an open loop gain 100 dB and unity gain bandwidth 3 megahertz. And then the solution here, they say for non-inverting. That means this circuit. First one, the closed loop gain ACL equal 1 plus RF over RI. So FC equal BWCL equal unity gain bandwidth divide ACL. And unity gain bandwidth, they given you 3 megahertz. You take 3 megahertz, divide to the gain, and you get 44.3 kilohertz. Okay? Basically, you don't have to do anything at work. Okay? And another one for non-inverting, then you have to calculate ACL. Yeah. And FC equal unity gain bandwidth divide ACL. Okay? Different amplifier. That coming out from op-amp level. The difference from amplifier. You get two input that amplify. The difference between V1 and V2. V1 is connected to the inverting. V up V1, V2 is connected to non-inverting. Okay? So that one, sometimes you reading here, and if you still need more time, keep going. That's just waste of time. So that's why you copy that, say to the PowerPoint. Later on, you get the time. You can do it. Okay? So in here, you already know how to calculate that. For V1, VL equal. Okay? When you're looking into the circuitry here, you can see They apply V1 to negative, V2 to positive. That's what they call a differential amplifier. So, in order to solving a problem, first thing, you have to solving for input V1. So what happened to the V2? So you have to using superposition in a DC. That means you round V2 and working with V1. Okay? So for V1, V out equal, okay, minus, okay, V1 times the gain R5 over R1. Okay? And now if you want to working on V2, then you have to round V1. That means we want 0 in here. So we're working on V2, they will be non-inverting amplifier. So V out equal V2 times R4 divided R2 plus R4. That means you get a V2. However, the input must be this point. Then you have to using voltage divider to calculate the voltage here. V2 times R4 divided R2 plus R4. And multiply by the gain. The gain will be 1 plus R5 over R1. So again, when you get both input applied to the op-amp, there will be a differential amplifier. For differential amplifier, if you're working with the V1 input, then you must route it V2. So V1 will be non-inverting amplifier. Okay? And when you want to working on a V2, then you have to route V1. Okay? They will be a non-inverting amplifier. That will be telling you you can get V out and in inverting or non-inverting.
And Mr.
Okay?
Mayor,
Yeah.
on that same circuit, if you was to build that on multi-sim 7, you would do the same thing, work on V2, so ground V1, or work on V1, ground, vice
Yeah.
versa.
But the thing I will understand, if you're working on a MSIM7, they just given to you. If you given input V1, V2, they given you V out. No explanation. That's just a measure.
Yeah,
But
but what I'm saying is when you build the circuit, you would ground V1 and work on V2, then go back and ground V2 and work on V1.
that's how to calculate it. But you cannot route it. If you want it, you can route it and try to see what you get for non-inverting amplifier. And you can route V1 and working on V2, okay, to get an non-inverting.
So my basic question is, you on a multi-sim 7, you can ground them, right?
Yeah, you can route one.
Okay, thank you.
Okay, I try to repeat again. when you're looking into that circuitry, okay, if V1, V2 equal 6 volt, what Vout equal? So if you enter A, they fail, B fail, and C, they will be correct. After you get correct, copy that into the PowerPoint. For later on, when you wanted to know more detail, you go into your PowerPoint. You can see that. Okay? Don't try to spend too much time. Just try to see, can we calculate it? If you already know, you calculate it easy. No big deal. However, still confusing. Don't waste the time on left phone. We want you to do working on that. Okay? So when you're going to the next, they're telling you C will be the correct one. So make sure you copy that later on. Easy for you to analyze. Okay? So let's see. I can go to that one. I will be stop it, okay? Will be continue next one. Okay, now on this one, in this circuit, sideways generator apply an unwanted common mode input voltage. They call it VCM to both input. That means they connect the generator to V1 and also V2. Due to the common mode rejection of V1, the sideway does not appear at the Vout. That means at the output you cannot see the sideway. Common mode input voltage appear across inverting or non-inverting input of a different amplifier, across both input of different amplifier. Okay? In this different amplifier, R1, R2, R4, R5, same value due to the resistor value Vout equal V2 minus V1, or the difference between the input voltage. The output voltage polarity is determined by relation between non-inverting input voltage V2 to the inverting input V1. The V2 polarity dominates the V1 polarity and determine the output voltage. Okay? And that will be the showing you, okay, what Vout equal VA. That means that point here, okay, voltage divider, and VD 0, VA equal VR4, okay, that means that's a VA, okay, they're not using VR2. Okay, so in this circuit R1 is used to switch V to V1. That means you can connect to V2 or you go connect to V1. Okay, vary between 0 and 10 volt DC. It's only 0 volt for either at one position, vary between 0 and minus 10 volt. Both A and C depend on position at one. And the multiple choice. And they give you 4 volt pick-to-pick answer. Okay? Oh, man. Lucky. They will be the end. Okay, any question?
Good job. Thanks a lot, Mr. Pham.
Yeah, no problem. Okay? The thing is sometime, okay, you have to go to more time so you in order to understand. Okay? Otherwise, no way you can understand it. So make sure you have to download assignment and try to working on that. Any assignment you cannot get it passed, just text to me. I can telling you what's going on, what's wrong, to solving your problem. The thing is now we're using the canvas, okay? CT control everything. I cannot do anything else. Can help you if you cannot get through it. Okay? So, good night
Hey,
to
Mr.
all of
Pham,
you.
real quick.
Yes, sir.
Um, when I'm trying to upload the XL, at the end of the XL, it's got XL something, and then on the canvas, when you try to upload, it's got XLN or something. So some extensions it don't accept.
Now, normally, after you get done for assignment, you go to the canvas, okay, to click on upload assignment.
I know, but that's what I'm saying. I tried to do it with some. There's been some times where we tried to do it with the XL and it wouldn't upload. I
Okay,
don't know why, because I followed the instructions that you gave on that paper that you gave like a little handout.
okay, now, let's see. You can see canvas on
Yeah, I
the,
know what you're talking about.
I try to display the canvas on the, let's see, on the display on the Zoom. Can you see it? I have to share, right?
Yeah, right now the only thing I see is your name.
Okay. You see that canvas? The
Yeah,
web.
right there. Go ahead.
Okay. You go to the canvas.
Right.
Okay. Go to take one. Assignment. Okay. And assignment. You click here. Let's see. I have to log into view as student. Okay. That will be view as student.
Okay. Hey, Mr. Pham, hold that right there. Because this is what I'm talking about. See how at the end of that XL, it's got XLSX? on one of the upload things on the canvas, it's got XLN. It accept that, but not the XLSX.
Now, that doesn't matter. I'm telling you, how can we do? Now, if you see here, okay, you want to upload assignment 9, okay?
Okay,
Click on assignment 9, okay? And let's see, you see, click on re-upload submission, okay?
all right.
Let's see. You see, click in here, you get upload document, okay? Then you move the file into here.
Yeah, I know, but
Now
when
they
I
don't care. They don't care about XL or whatever.
well, that's what it said. It said didn't accept it.
What?
When I clicked on it, it said it wouldn't let me upload the Excel
Now, okay. Now let's see. Uh,
because that's the exact screen I was on.
okay. For example, okay. That's number 9, right? You go into your computer, select number 9. You already done. You click on number 9 file and put in here and click submit.
No, I agree with you, but I'm just saying for whatever reason it didn't work.
Now,
But
I
for other people it did, so I don't know.
and you say, okay, okay. So now you can see you uploaded and I can
No,
see what you're doing.
no, I agree with you, Mr. Pham. I don't know why it didn't go through, so I don't know.
Oh, okay, so try it.
Okay,
So,
but thank you very much.
yeah, no problem. Okay, good night, everyone.
Good night.